Well, welcome back to our class on software engineering. We're working through this fourth section where we're talking about software management. We've talked about project management. We talked about project planning. And for this lecture, we're going to be talking about quality management. So the things that we'll be getting into in terms of quality management are software quality, software standards, review and inspection, quality management and agile development, and finally software measure. For software quality management, this is concerned with ensuring that the required level of quality is achieved in a software product. There's three principles at the organization level, project level, and then some more details on that. So at the organization level, the quality management is concerned with establishing a framework of organizational processes and standards. At the project level, the quality management involves the application of specific quality processes and checking these. And also the quality management is also concerned with establishing a quality plan for the project. The quality plan should be set out with quality goals and the project for the project and define the processes and standards that will be used. For the quality management activities, the quality management process provides an independent check on the software development process. Quality management process checks the project deliverables to ensure that they are consistent with organizational standards and goals. And the quality team should be independent from the development team so that they can take an objective view of the software. This allows them to report on the software quality without being influenced by software development issues. So here is an example how quality management and software development play out. So you have the software development process, and then you have the quality management process. And so they're working in parallel as they're going through the process. For quality planning, a quality plan sets out the desired product qualities and how these are assessed and defines the most significant quality attributes. The quality plan should define the quality assessment process, and it should set out which organizational standards should be applied and where necessary define new standards to be used. Here is the quality plan, the structure. You want to have an introduction, you have product plans, a description, the quality goals, and then a discussion of risk and risk management. It should be short and succinct, and a lot of times that can mean the difference between somebody reading it versus not. For the scope of the quality management is particularly important for large complex systems. The quality document is a record of progress and supports continuity of the development as a development team changes. For smaller systems, quality management needs less documentation and should focus on establishing a quality culture. Techniques have to evolve when agile development is used. For software quality, software simplistically means that a product should meet its specification. This is problematic for software systems since there is tension between the quality, customer quality requirements, and the development quality. Some quality requirements are difficult to specify in an unambiguous way, and software specifications are usually incomplete. The focus may be fitness for purpose rather than specification conformance. So let's talk more about this fitness for purpose and what would be the kind of questions that you would ask. Has the software been properly tested? Does it have sufficiently dependable to be put into use? Is the performance acceptable for normal use? Is the software usable? Is the software well structured and understandable? And finally, have programming and documentation standards been followed in the development process? For non-functional characteristics, the subjective quality of software systems is largely based on non-functional characteristics. This reflects practical user experience. If the software's functionality is not what is expected, then users will often just work around this and find other ways to do what they want to do. However, if the software is unreliable or too slow, then it is practically impossible for them to achieve their goals. So here are some quality attributes. Sometimes I've heard the term ilities, and so there's a lot of different ilities that are here. that would be part of the quality attributes you would look for. What about quality conflicts? It's not possible for any system to be optimized for all of these attributes. For example, improving robustness may lead to loss of performance. The quality plan should therefore define the most important quality attributes for the software that is being developed. The plan should also include a definition of the quality assessment process as an agreed way of assessing whether some qualities such as the maintainability or robustness is present in the product. For process and product quality, the quality of a developed product is influenced by the quality of the production process. This is important in software development as some product quality attributes are hard to assess. However, there is a very complex and poorly understood relationship between software process and product quality. The application of individual skills and experience is particularly important in software development. External factors such as the novelty of the application or the need for the accelerated development schedule may impair product quality. Here is a flow diagram of the process-based quality. So you define the process, and then there's a loop where you're trying to evaluate how well that is working. And eventually you come to a standardized process that is agreed upon. For quality culture, quality managers should aim to develop a quality culture where everyone is responsible for the software development. They should encourage teams to take responsibility for the quality of their work and develop new approaches to quality improvement. And they should support people who are interested in the intangible aspects of quality and encourage professional behavior in all team members. Let's talk about software standards. Standards define the required attributes of a product or a process. They play an important role in the quality management. Standards may be international, national, organizational, or project standards. For the importance of standards, encapsulation of best practices avoids repetition of past mistakes. They are a framework for defining what quality means in a particular setting. For example, with the organization's view of quality, they improve continuity. New staff can understand the organization by understanding the standards that are used. For product and process standards, for product standards, these apply to the software product being developed. So there's various things that would be part of that. And there's also process standards. These define the process that should be involved during the software development. Process standard may include definitions, specifications, etc. Here are product and process standards. Some of these standards, you have the design review form, there's the requirements document structure, method header format, Java programming style, programming plan format, and change request forms. So there's a variety of different, so you have product standards and then you have process standards, design review conduct, submission of new code, verification, project plans, change control, and test recording process. What about problems with standards? They may not be seen as relevant and up to date by software engineers. They often involve too much bureaucratic form filling. And if they are unsupported by software tools, tedious form filling work is often involved to maintain the documentation associated with the standards. For standard development, this involved practitioners in development. Engineers should understand the rationale underlying a standard, review standards and their usage regularly, and standards quickly become outdated, and this reduces their credibility among practitioners. Detailed standards should have specialized tool support. Excessive clerical work is the most significant complaint against standards. For the ISO 9001 standard framework, an international set of standards that can be used as a basis for developing quality standards is this. So ISO 9001, the most general of these standards, applies to organizations that design, develop, and maintain products, including software. The ISO 9001 standards are a framework for developing software standards. So here is a listing of the ISO 9001 core processes. So there's product delivery processes, there's supporting processes, and so we can see that. And also there can be an organization quality manual and how that flows. And So these are a couple of references that you can look at in more detail. For ISO 9001 certification, quality standards and procedures should be documented in an organizational quality manual. An external body may certify that an organization quality manual conforms to the ISO 9000 standard, and some customers require suppliers to be ISO 9000 certified, although the need for flexibility here is increasingly recognized. So for software quality and the ISO 9001, ISO 9001 certification is inadequate because it defines quality to be the conformance to standard. It takes no account of quality as experienced by the users of the software. And unfortunately, the standard can be met by incomplete software testing that does not include tests with different method parameters. And so there's some things to be considered. In terms of reviews and inspection, a group examines part or all the process of or systems in its documentation to find potential problems. Software or documents may be signed off at a review, which signifies that the process to the next development stage has been approved by management. There are different types of reviews, and so inspections, reviews for progress, and then quality reviews. For quality reviews, a group of people carefully examines parts of the software and associated documentation, code, design, specification, test plans, standards, et cetera, can be reviewed, and software documents can be signed off, quote, at a review, which signifies that the process to the next development stage has been approved by management. What are the stages in the review process? There's pre-review activities, and there's activities during the review and then post-review. Pre-review activities are concerned with reviewing planning and preparation during the meeting, and the author of the document or program being delivered should walk through the documents, and then after that, the review, these address the problems and issues that have been raised during the review meeting. So this is just giving you a pictorial view of the process of the pre-review, actually having a meeting, and then the post-review. In terms of distributed review, the processes suggest for reviews assume that the review team has a face-to-face meeting to discuss the software documents that they are reviewing. However, project teams are now often distributed, sometimes across countries or continents, so it is impractical for team members to meet face-to-face. Remote reviews can be supported using shared documents where each review team members can annotate the document with their comments. For program inspections, these are peer reviews with engineers examining the source of the system with the aim of discovering anomalies and defects. Inspections do not require execution of the system, so may be used before implementation. They may be applied to any representation of the system, and they have been shown to be an effective technique for discovering program errors. For inspection checklists, checklists of common errors should be used to drive the inspection. Error checklists are programming language dependent and reflect the characteristic errors that are likely to arise in the language. In general, the quote, weaker the type checking, the larger the checklist. Examples could be initialization, constant naming, loop determination, array bounds, etc. Here are some listing of things that could be on an inspection list. And so you can have data faults, control faults, input and output faults, and I won't go through the details here. You can look that over at your leisure. You can have interface faults. You can have storage management faults, and you can have exception management faults. And so those are the various things that you could have included on an inspection checklist. For quality management and agile development, quality management in agile development is informal rather than document-based. It relies on establishing a quality culture where all team members feel responsible for software quality and take action to ensure the quality is maintained. The agile community is fundamentally opposed to what it sees as bureaucratic overheads of standard-based approaches like the ISO 9001. For shared good practices, you would have a check before check-in. Programmers are responsible for organizing their code reviews with others. Never break the build. Team members should not check in code that causes the system to fail. Developers have to test the code changes against the whole system. And you fix problems when you see them. If a programmer discovers problems or obscurities in code developed by someone else, they can fix these directly rather than referring them back to the original developer. For reviews in Agile method, the review process in Agile software development is usually informal. In Scrum, there is a review meeting after each iteration of the software has been completed, a sprint review where quality issues and problems may be discussed. In extreme programming, pair programming ensures that code is constantly being examined and reviewed by another team member. For pair programming, this is an approach where two people are responsible for code developments and work together to achieve this. Code developed by an individual is therefore constantly being examined and reviewed by another team member. Pair programming leads to a deep knowledge of a program, as both programmers have to understand the program in detail to continue development. And this depth of knowledge is difficult to achieve in inspection processes, and pair programming can find bugs that would not be discovered in formal inspections. For what are some of the weaknesses in pair programming? There can be a mutual misunderstanding, so both of them are seeing it from the same perspective. There can be pair reputation. Pairs may be reluctant to look for errors because they do not want to slow down the progress. In working relationships, a pair's ability to discover defects is likely to be compromised by their close working relationship that can often lead to reluctance to criticize work partners. For Agile quality management in large systems, when a large system is being developed for an external customer, Agile approaches to quality management with minimal documentation may be impractical. The customer is a large company and may have its own quality management processes, where there are several geographically distributed teams, perhaps from different companies. The informal communication may be impractical. For long lifetime systems, the team development involved in development will change. Without documentation, new team members may find it impossible to understand development. Let's talk about software measurement. Software measurement is concerned with deriving a numeric value for an attribute of a software product or process. This allows for objective comparisons between techniques and processes. Although some companies have introduced measurement programs, most organizations still don't make systematic use of software measurement. There are a few established standards in this area. For software metrics, any type of measurement which relates to a software system, process, or related document, it allows for software and the software process to be quantified. It may be used to predict product attributes to control the software process. And finally, product metrics can be used for general predictions or to identify anomalous components. What are the types of process metrics? Here's a handful: the time taken for a particular process to complete, the resources required for a particular process, and the number of occurrence of a particular event. Here is a diagram showing the predictor and control measurements, how that could work. So you can look that over at your leisure. What about the use of measurements? To assign a value to a system quality attributes by measuring the characteristics of system components, you can assess system quality attributes such as maintainability. To identify the system components whose quality is substandard, measurements can identify individual components with characteristics that deviate from the norm. So that can be something to look out for. What are some metric assumptions? A software property can be measured accurately. The relationship exists between what can be measured and what we want to know. This relationship has to be formalized and validated. And it may be difficult to relate what can be measured to desirable external quality attributes. Here are some relationships between the internal and external software. And so you have these various quality attributes: maintainability, reliability, reusability, and usability. All these fold over into the internal. So the external goes to the internal, the inheritance tree, complexity, program size, number of errors, and length of the user manual. In terms of problems with measurement in industry, it is impossible to quantify the return on investment of introducing an organizational metric program. There are no standards for software metrics or standardized processes for measurement and analysis. In many companies, software processes are not standardized and are poorly defined and controlled. Most work on software measurements has focused on code-based metrics and plan-driven processes. Introducing measurement adds additional overhead to processes. For empirical software engineering, software measurements and metrics are the basis of empirical software engineering. This is a research area in which experiments on software systems and the collection of data about real projects have been used to form and validate hypotheses about software engineering methods and techniques. Research on empirical software engineering, this has not had a significant impact on software engineering practice. It is difficult to relate generic research to a project that is different from the research study. So that's another thing to be thinking about. For product metrics, a quality metric should be a predictor of product quality. Classes of product metrics, it can be dynamic metrics, static metrics, and so for dynamic metrics, it can be collected by measurements made of a program and execution. There can be static metrics, which are collected by measurements made of a system's representation. You can have diametric metrics that help assess efficiency and reliability. And finally, you can have static metrics that help assess complexity, understandability, and maintainability. For dynamic and static measurements, dynamic metrics are closely related to software quality attributes, while static metrics have an indirect relationship with quality attributes. Here's a listing of static software product metrics, and I'll just quickly go over the names of these, and you can spend time to look over this in more detail as you would like. So there can be fan in and fan out. There can be the length of the code. There can be the cyclomatic complexity, the length of identifiers, the depth of conditional nesting, the fog index. You can have the weighted metrics per class, the depth of the inheritance tree, the number of children. Finally, the coupling between object classes, the response for a class, and the lack of cohesion methods. So a variety of things that can be used for this whole process. For software component analysis, system components can be analyzed separately using a range of metrics. The value of these metrics may be compared for different components and perhaps with historic measurements, data collected on previous projects. Anomalous measurements which deviate significantly from the norm may imply that there are problems with the quality of these components. So here is a process showing the process of a product measurement. And so you can see how that generally flows. In terms of measurement ambiguity, when one collects quantitative data about software and software process, you have to analyze the data to understand its meaning. It's easy to misinterpret data and to make inferences that are incorrect. Unfortunately, you can't just simply look at the data on its own. You must consider the context where the data is collected. In terms of measurement surprises, reducing the number of faults in a program leads to increased number of help desk calls. The program is now thought of as more reliable, so has a wider, more diverse market. A more reliable system is used in a different way from the system where users work around the faults. And so these are some things that may come up and reduce to more calls. For software context, processes and products that are being measured are not insulated from their environment. The business environment is constantly changing, and it's impossible to avoid changes to work practices just because they may make comparisons of data invalid. Data about human activities cannot always be taken at face value. The reasons why a measurement value changes are often ambiguous. These reasons must be investigated in detail before drawing conclusions from any measurements they have been made. For software analytics is analytics on software data for managers and software engineers with the aim of empowering software development individuals and teams to gain and share insight from the data to make better decisions. What are some of the enablers? the automatic collection of data, user data by software product companies. That's something that can be useful. If the software fails, information about the failure and the state of the system can be sent. The use of open source software available on platforms such as SourceForge and GitHub and open source repositories. The source code of open source software is available for automated analysis and then can sometimes be linked with data in the open source repository. For analytic tool use, tools should be easy to use, as managers are unlikely to have experience with analytics. They should run quickly. They should make measurements using as many parameters as possible, and tools should be interactive and allow managers and developers to explore the analyses. For status of software analytics, software analytics is still immature and early, too early to say whether it will affect what effect it will have. Not only are there general problems of big data processing, our knowledge depends on collecting data from large companies. Small companies are unlikely to invest in these data collecting systems that are required for automated analysis, so may not be able to use the software analytics. All right, well, let's finish up with some key points. Software quality management is concerned with ensuring that software has a low number of defects and it reaches the required standard of maintainability, reliability, portability, et cetera. Software standards are important for quality assurance as they represent an identification of best practice. When developing software, standards provide a solid foundation for building good quality software. Reviews of software process deliverables involves a team of people who check the quality standards are being followed. Reviews are the most widely used technique to assess quality. In a program inspection or peer review, a small team systematically checks the code. They read the code in detail and look for possible errors and omission. The problems detected are discussed at a code review meeting. Agile quality management relies on establishing a quality culture where the development team works together to improve software quality. Software measurement can be used to gather quantitative data about software and the software process. You may be able to use the value of the software metrics that are collected to make inferences about product and process quality. Product quality metrics are particularly useful for highlighting anomalous components that may have quality problems. These components should then be analyzed in more detail. Software analytics is the automated analysis of large volumes of software products and process to discover process data to discover relationships that may provide insight for project managers and developers. Okay, that will end our lecture. Thank you very much.